Welcome students. We now come to the topic of galvanometer. So galvanometer, and as you can see, it is also can be used as a voltmeter and ammeter. So what I would say is that galvanometer is a universal set where the subsets are ammeter and voltmeter. So that is what you have to understand, that the same instrument galvanometer can be used as an ammeter and as a voltmeter. So galvanometer basically is a instrument or a device which uses magnetic effect of current. So galvanometer is based on magnetic effect of current, and we have to primarily know that how the galvanometer can be used as an ammeter and how it can be used as a voltmeter. So for the ammeter part, what we can say, as you can all know, that the ammeter is fundamentally used to measure the current of a circuit, and it is primarily a galvanometer which is connected with a very low resistance in parallel called shunt. Now this is a technical name of this low resistance in parallel, which is shunt. Now as you can see, this is the line current I, this is the galvanometer current Ig, and this from Kirchhoff's law is I minus Ig. Now as this galvanometer and this shunt, as we will call it, the low resistance, is in parallel, so the voltage across these 2 points should be same. So we can go on to write that Ig into G, the product of current and resistance here, should be equal to the product of current and resistance there. Why? Because the voltage is same across the 2 points. So we can go on to write I minus Ig into S. So that will give us the value of the shunt, where we can determine the ammeter reading or the value of the ammeter reading. So this is actually the value of shunt that we require. Now there are some people who go on to write this as this, G n minus 1. As you can understand, this n is nothing but the ratio of I by Ig. So here fundamentally what we are doing is dividing both the numerator and the denominator with the galvanometer current, and we have n. So n is basically the ratio of I and Ig, and n is also known as a multiplication factor. So the n, as we call it, a multiplication factor. Now it is also called the sensitivity, and as you can see, it is a ratio of I by Ig. So this is all we can have right now for the ammeter. Now the voltmeter is basically a galvanometer where there is a high resistance in series associated with the galvanometer. So this primarily is a voltmeter, and we can measure the voltage across these 2 points. This is what we call the voltage measured by the voltmeter, and we have the current here as Ig. The same current which flows through the galvanometer flows through the resistance R. So here we are fundamentally apply the Ohm's law, which is V is equal to Ig into G plus R, and from there we go on to find R, the unknown resistance, which is required to be connected in series with the galvanometer to convert the galvanometer to a voltmeter. And the value of R, as you can see from here, the equation is V by Ig minus G. So I will repeat that the same galvanometer can be used as an ammeter, can be used as a voltmeter. Only the point remains that the two applications are quite different. So I will repeat that an ammeter is primarily a device which looks like this with a shunt, and this whole arrangement is what is called an ammeter. This whole arrangement is what is called an ammeter. And this ammeter, when connected in a circuit, is always connected in series to a circuit. So an ammeter is always connected in series to a circuit, while the voltmeter, as you can see, it is an apparatus which looks like this. So this is the whole thing what we call a voltmeter. And whenever you connect a voltmeter, we connect it in parallel to a circuit. So it is very important for us to memorize that we apply the voltmeter in parallel to a circuit and an ammeter in a series to a circuit. So this is primarily the very important aspects that we need to learn for ammeter and voltmeter. So I will repeat that the same galvanometer is used as an ammeter and voltmeter, only that they are connected either in parallel or in series, and the whole ammeter is then taken to its circuit in series. The whole voltmeter is taken in the circuit to parallel. Well, that's all, students, right now. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.